Hi guys, so let's do surds today, right? What does surds mean? So a surd is a square root. It's a square root number that doesn't give a whole number as an answer, right? Like if you say square root of 4, that gives you 2, right? So that is not a surd. But when you do square root of 3, that does not give you a whole number as an answer, right? So that is a surd. So that is square root of 3, or you can say square root of 2, etc. Right? Now more generally, we get a surd when we take the square root of a number. So we do a square root of a number that isn't a square number. So 4 is a square number. Then if you say 25, that is a square number. So when you do square root of that, you get 5. Right? Square root of 36 is 6. So these numbers are not surds. Right? The numbers such as square root of 5, square root of 6, square root of 7, square root of 8, these numbers are surds that do not give you a whole number as an answer. Right? So today we are going to do 7 key skills that you need to learn how to manipulate surds or how to solve surds. Right? Cool. So let's start with multiplying surds first. So we're starting multiplying. So as we do, 7 times 2 is equals to 14, right? Similarly, when we do square root of 7 times square root of 2, both square root 7 and square root 2 are surds. We do square root of 7 times 14. Sorry, 7 times 2, right? So that gives you square root of 14. So we can say that square root of first number times square root of second number will give you square root of first number times the second number. Right? Let's do one more example, and let's say we have square root of 5 times square root of 6, right? And we will say the answer will be square root of 5 times 6. That gives us square root of 30. Right? Another example that we could do is slightly difficult. So we can do 3 square root of 5 times 2 square root of, let us suppose, 3. Right? So in this case, what we do is we take the numbers which are outside, times them together first, and then square root, and then the numbers which are inside the square root comes together. 5 times 3, so that gives us 6 square root of 15. Right? Let's do one more example. Let's do square root of 3 and then square. Right? Squaring means you're timesing the number together. So that will give you square root of 3 times square root of 3. And square root of 3 times square root of 3 gives you square root of 3 times 3, which is square root of 9, and square root of 9 gives us 3. Right? Last example in this could be square root of 5 to a greater power. So a greater power, let us suppose we take power of 5. Right? We are taking a greater power. So we will do square root of 5 times 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 square root of 5. Right? Now, in the previous question, we have done that when we have the power as square, it gives us the same number just without square root. Right? Because square and square root, square and square root can cancel each other, right? So in this case, we have 2 squares here. We have, square root here and 2 square roots here. So we can, just finding it easier to do, square root of 5 times square root of 5 becomes 5, times another square root of 5, square root of 5 will become 5, times you're left with square root of 5. So that gives you 25 square root of 5. Right? Or another way of solving it, and like the basic way of solving it could be, you will do square root of 5 times 5 is 25, times 5 is 125, times 5 is 625, times 5 625, times 5, let's times them together, 5, 2, 10, 12, 30, 3125, it gives you 3125, and then again 3125, you will have to find the square numbers, which is the closest square number. We are going to do such questions in the next video, some difficult questions. So that will give you 25 times 25 times 5, and that gives you 25 square root of 5, right? But I prefer the first method, where you can split them around and then you can work in batches rather than working it together as a big number. Great. So that was multiplying surds. In the next video, we are going to do dividing surds. Stay tuned and make sure you subscribe to the channel. Have a good day. Hi guys. So today we are doing dividing surds, right? This is video 2 of the surds series. If you haven't watched the first one, in the first one we did multiplying surds and introduction to surds. So if you haven't watched that, make sure you go back and watch that. I'll put the link in the description below. Make sure you subscribe to watch the entire series. Great. Let's get started. So we are doing dividing surds. Now, in division of surds, when we have first surd divided by the next number, it could be any number, doesn't matter. So first surd divided by second surd is equals to square root of first number divided by second number. And I'm sure you know that a divided by b is same as a fraction b. So fraction and division is kind of the same thing here, right? So let's do example 1. So let us suppose we have square root of 3 divided by square root of 5, right? So that will give us square root of 3 over 5, right? So you can leave that as an answer. So next one, let's do square root of 2 over square root of 6. So that will become square root of 2 over 6, and that gives you square root of 1 over 3, right? You can, or you should, simplify what's inside the bracket or what's inside the square root, right? Right, so next example could be 2 square root of 12 over 3 square root of 4, right? So that will be 2 over 3, right? Square root of 12 over 4, right? So 2 over 3 remains 2 over 3. 12 divided by 4 is 3. So that gives us square root of 3, right? And last one, let's do one more. Last one will be, let us suppose 5 square root of 100 over 2 square root of 10, right? So that will give us 5 over 2 square root of 100 over 10. So 5 over 2, 100 divided by 10 is 10. So that leaves us 5 square root of 10, right? I hope this helps. Now stay tuned for the next skill, and next skill is going to be adding and subtracting surds. Make sure you subscribe and watch the next video in the series. Great. Have a good day. Hi guys. So we are on part 3 of surds. And today we are doing adding and subtracting. In our previous 2 parts, we have done multiplying and dividing surds. You can find those videos in the description below. Right, so let's get started. When we are adding and subtracting surds, we need to make sure that we are treating them as like terms. Right? What does that mean is, when you have, so like in like terms, you are doing a plus b. So let us suppose you're simplifying that. So you can only add a and a together. That becomes 2a, and b is a different variable. So it stays separate. Same rule applies when adding surds. What we do is, let us suppose we have root of a plus a root of a plus a root of b. Okay, so when we have like this, we can only add root a and root a together. So that will become 2 root a, and root b is separate. All right, we cannot add it together, right? Similarly, let us suppose we have root 2. So for example, let us suppose we have root 2 plus root 3 plus root 2 plus, let us suppose anything else, root 5, right? So here again we have to find the common surds. So root 2 and root 2 can go together. Root 5 and root 3 are different, so they cannot go together. So the answer here will be root 2 or 2 root 2, because there are 2 root 2's, plus root 3 plus root 5, right? We have to treat them as like terms, right? Let's do another one. So let us suppose we have 2 root 5 plus 3 root 5 minus root 5. Let us suppose we have to simplify this. So first thing we will see, all the terms have root 5, so that means we can solve them together, or we can simplify them. So 2 plus 3 root 5s will give us 5 root 5, and then take away 1 root 5 from it will give us 4 root 5. All right, so now let's do a couple more. So it's 2, so let's do 2 square root of 3 plus 5 square root of 27, right? So here we will have to simplify one of the surds, right? So it becomes 2 root 3. We cannot simplify root 3 further, but we can simplify root 27, right? Because 27 is 3 times 9, and 9 is a square number, right? So we can write it as square root of 3 times 9. And 9 can be written as 3 square, and in our previous video we have done that square and square root can cancel, right? So we can take 1 3 out, and it can be written as 3 root 3, right? So now that becomes 5 times 3 root 3. So now question is simplified further. 2 root 3 plus 3 times 5 is 15 root 3. And now we can add 2 root 3 and 15 will give us 17 root 3. That's our answer. Great. Let's do one more question of this type. So it is, let us suppose we have 6 root 6 plus 3 root 24. Right. So here 6 cannot be simplified further. So we will write 6 root 6 as it is. Whereas 24 can be written as square root of 4 times 6, right? Here the rule is we try and find one of the factor as a square if we can find that. So here 4 is a square number, so we try and find one of that factor, because then 4 can be written as 2 square, and then it will come out of the square root. It will leave as 2 square root of 6, right? So it becomes 3 times 2 square root of 6. So 6 square root of 6 plus 3 times 2 is 6 square root of 6. And now we are left with 6 square root 6 plus 6 square root 6 gives us 12 square root of 6. Great. I hope this makes sense. Our next video will be on simplifying surds, and simplifying more of this, and a little bit of challenging questions as well. So make sure you subscribe and press that bell icon so you don't miss that video. Great. Have a good day. Hi guys. So this is part 4 of the Surds series. We have done multiplication, division, adding and subtracting in our previous 3 videos. And in this video we are doing simplifying surds. Right? So the rule to simplify surds is to find the factor which is a square number. All right, so our main aim is to find the factor. So let us suppose we have square root of 28 and we have to simplify this. Now factors of 28 that I can think of is 4 times 7, right? And 4 is a square number, right? So our aim is to find one of the factor as a square number at least, right? What that does is that can make square root of 4 can be written as 2 squared and then times 7. In our squaring factors video, we have done that square root of 2 times square root of 7 gives us square root of 2 times 7, right? So we can do it the opposite way as well. So here when we split the bracket, that will give us square root of 2 squared times square root of 7, right? And 2 square and square root and square can cancel, will give us 2 times square root of 7. That can be written as 2 square root of 7, right? I hope this makes sense. Let's do one more of a similar question. So let us suppose we have another number as square root of 720. Right? So here when I look at this number, I cannot think of a square number straight away. Well, you might. What I do is I just write down the factors that I can think of, right? So I can think of 72 and 10 as a factor, right? So 720 can be written as square root of 72 times 10, right? And using the same rule, I can split it into square root of 72 and square root of 10, right? Now, when I think of 72 and 10, I can think of some factors of them. All right, so when I think of 72, I know that 36 is a factor and 36 times 2 give me 72, and 36 is a square number. So now in this case I can find a square number as a factor, right? We do the same with 10, and 10 doesn't have a square number, but it has square root of 2 times square root of 5, right? So now we have one square number, we have 2 square roots, and we have a root 5, right? What we do here is we know that 6 square gives us 36, so we can write it as 6 square, square root of 6 square. Then square root 2 and square root 2 can be written as square root square, okay? And then we have root 5 there, okay? And this together makes square root of 720. So again, we are on the right track. Now 6 square and square root will give us 6. Square root square gives us 2, right? Because square and square root will cancel again. So if you are doing it this way, it leaves us with 6. And if you are doing it this way, whole square, then also it gives. And these are really important skills to remember. And square root 5 doesn't have a pair, so square root 5 stays itself. Now we can solve it further and it gives us 12 square root of 5, right? If you can think of a factor here at the start, if you can think of 36 as a factor there itself, so 36 times 20, right? If you can think here, then again you can continue with the tree and it will give you square root of 6 squared, and then here you can have 4 times 5, right? You can follow a different path with the different factors, so it will give you 6 times 2 square root of 5, and again you are left with 12 square root of 5. So no matter what factors you start with, you end up with the same answer. Great. And there are 2 very important skills in here that usually students make mistakes in, right? Our next video is going to be on double brackets and surds, very important skill in surds. And have a good day. Hi guys, so today we are doing double brackets in surds, alright, and it works the same as algebra. So as we solve double brackets in algebra, the same method is used here. So like you have in algebra, a plus b and c plus d, let us suppose. So we are going to a times c will give us ac plus A times D will give us AD plus BC plus BD, right? The same method is applied in Surds. So for example, let's take square root of 2 plus square root of 3 in one bracket and square root of 5 plus square root of 7 in another bracket. How do we solve this? So square root 2 times square root 5 will give us square root of 10. Square root 2 times square root of 7 will give us square root of 14, plus square root 3 times square root of 5 gives us square root of 15, plus square root 3 times square root 7 gives us square root of 21, and that is the answer here. All right. Another example could be square root of 2 plus square root of 3, and then square root of 2 minus square root of 3. So what happens here is mostly in exams they give conjugate pairs, right? So these here are called conjugate pairs because there are same numbers, just different signs in between, right? So how do we solve this? You can use the same method as multiplying each number with the other, or you can use A plus B and A minus B algebraic identity, and it is equals to A square minus B square. Okay, these identities are really important to learn if you want to do higher algebra, right? So here this can be A plus B and this is A minus B, so it gives us A square minus B square, which is root 2 square minus root 3 square. Root 2 square will be 2 minus root 3 square is 3, so answer is equals to minus 1. All right, let's do another question where we'll be use another identity. So let us suppose we have root 5 minus root 3 whole square. All right, again it is two brackets there because it is square, and we can use A minus B whole square identity, which is A squared minus 2AB plus B square. Right, so again we will do A, which is root 5 squared minus 2 times root 5 times root 3 plus root 3 square, right? And that leaves us with 5 minus 2 root 15 plus 3. Right, so 5 plus 3 is 8 minus 2 root 15, or we can simplify further and take 2 common, 4 minus root 15. Right, so that is your answer here. So let's do one last question. So let us suppose you have one number and another is a surd. So 3 plus root 5 and another one is 5 minus root 3, right? These are two separate different brackets. Again, number times number, so you're going to expand it the same way. 3 times 5 is 15. 3 times root 3 is minus 3 root 3. 5 times root 5 is plus 5 root 5. And root 5 times root 3 is root 15, right? So minus square root of 15. Here we cannot solve it further, so that is your answer, right? I hope it makes sense. Have a good day. Hi guys, so this is skill 6 in the Surds series, or part 6 in the Surds series. In this video we are going to cover two skills, so rationalizing the denominator, simple questions and difficult questions, and it is a very important skill for exams. All right, so these are the questions that usually turn up in the exam. So rationalizing the denominator means you need to get rid of surds from the denominator. All right, how do we do that? Let's see. So let us suppose we have a question of root 3 over root 5, all right? And the question is rationalize the denominator. So what we do is we times with the denominator. So we times and divide with the denominator, right? We do the same thing, right? So that will give us root 3 times root 5 gives us root 15, and root 5 times root 5 give us 5, right? That is how we rationalize the denominator. Let's do another one. So let us suppose we have 7 over root 3 this time. So what we will do is, again, we will times with root 3 on numerator and denominator both. So numerator will give us 7 root 3 and denominator will give us 3, right? So here we have rationalized our denominator because our denominators are whole numbers now. It's not a surd anymore, right? Now let's do some difficult ones or some harder ones. So in the harder one, let us suppose we have 7 minus root 3 over 7 plus root 3. So let's start with a common question. So usually you get these types of questions. Now here, just make sure you do not multiply only the surd. All right, very common mistake students do is just multiply with that surd. No, you do not multiply with the surd. You multiply with the conjugate. So conjugate of 7 plus root 3 is 7 minus root 3. All right, and if it is the other way around, so conjugate of 7 minus root 3 is 7 plus root 3. All right, so the numbers remain same, only the operation changes from plus to minus or minus to plus. Right, so here we will multiply and divide with the conjugate. So that will be 7 minus root 3 over 7 minus root 3. All right, so in the numerator you have the same, so you are going to use, you can use the algebraic identity. I always put an emphasis, learn the identity. So here you have a minus b and a minus b on the numerator, which becomes a minus b whole squared, and we know that it is a squared minus 2ab plus b squared, right? Always use identities, it just makes life so easy. So here when we use the identity, we will get 7 squared minus 2 times 7 times root 3 plus root 3 squared over, in the denominator now you have a plus b and a minus b. All right, so here we can use a squared minus b squared identity. So that is going to be 7 squared minus root 3 squared. Right, so when we solve it, we will get 49. 7 squared is 49 minus 2 times 7 is 14 root 3 plus 3 over 49 minus 3. And when you solve that, it becomes 49 plus 3 is 52 minus 14 root 3 over 49 minus 3 is 46, right? Now here we can see that we have even numbers in all the terms. So that means we can simplify it further, all right? So when we simplify it further, we can take 2 common from both numerator and denominator, right? So when we take 2 common from the numerator, we are left with 26 minus 7 root 3, and in the denominator we are left with 23. So 2 and 2 cancel, so this is a simplified answer, 26 minus 7 root 3 over 23. Right, I hope it makes sense. In the next videos, I'm going to do some exam questions, and those questions will have more of these rationalizing the denominator type questions. All right, so make sure you subscribe and continue watching Surds series and other scholarship questions that I have put it on. All the best. Hi guys, so let's simplify these two questions today. The first question is 2 square root 5 whole square, right? So what we have to do is we will do 2 square root 5 times 2 square root 5 because it is a square. So we will do whole number times whole number will give us 2 times 2, 4, and square root 5 times square root 5 will give us 5 straight away. All right, so it will be 4 times 5, which is 20. Right, now again, in case you do not know, square root 5 and square root 5 can be written as square root of 25, and that can be written as square root of 5 square, and square or square root can cancel, so that gives us 5, and that is where we have got this 5 from. All right, right. So now let's do the second question. So the second question says we have square root 2 over 2 square root 5 minus 3 square root 2, and we have to give our answer in the form of a plus square root b. Right, so first we will have to rationalize the denominator. So we will multiply and divide with the conjugate. So we have 2 square root 5 minus, so that minus will become plus because it is a conjugate, 3 square root 2 over 2 square root 5 plus 3 square root 2. Right, so in the numerator, now this square root 2 needs to be multiplied with both the terms. So that will give us 2 square root of 10 plus 3 square root of 4, and square root of 4 is 2. All right, so I'll write square root 4 for now, but next term, in the next term, square root of 4 will become square root of 4 is 2 square, so that will become 2. Right, so we will replace that soon. All right, so in the denominator we have a plus a minus b is the first term, and a plus b is the next term, so that will become a square minus b square. So that will be 2 square root 5 whole square minus 3 square root 2 whole square. All right, so now in the numerator we have 2 square root of 10 plus 3 times 2 is 6 over 2 square is 4, and 5 root 5 square is 5, so 4 times 5 is 20, minus 3 square is 9, and 2 square or root 2 square is 2, so that will give us 9 times 2 is 18. Right, so now let's simplify further. So we will get 2 root 10 plus 6, we can take 2 common, so we will be left with root 10 plus 3, and over 20 minus 18 is 2, so now that 2 and 2 will cancel, so we are left with root 10 plus 3. Right, now we have to give the answer in the form a plus root b, so root 10 is going to be root b, so we can write it as 3 plus root 10, and this is in the form of a plus root b. Right, I hope this makes sense. Right, have a good day.